Good morning, everybody. Welcome to Pi Academy, the place for mathematics and science. Yes, students, you all know that in the last class we were discussing the chapter light, reflection, and refraction. In that, we are in the last part of the chapter, last part of the concept called reflection. So, with respect to reflection, we were solving the problems on mirrors, right? And before going to continue to solve few more problems, just we shall recall the important terms related to mirror. In that, we have already come across one of the important mathematical statement which gives the relationship among focal length, object distance, and image distance. And this is also known as mirror formula. Then what is that mirror formula? Yes, it is 1 by f is equal to 1 by u plus 1 by v. This can also be read as the reciprocal of focal length of a mirror is equal to the sum of the reciprocals of object distance and image distance. And we have also, in this formula, when you know two terms, you can find out the third term. If you know object distance and image distance, you can find out the focal length of the mirror. Similarly, focal length and object distance is known. You can find out image distance, right? To know how big or how small the image of an object is, we will go for using another scientific term. What is that? It is called magnification. Magnification, it is the ratio of height of the image to the height of the object. And then what is the formula? It is m is equal to hi by h naught. And this can also be found out in terms of object distance and image distance. How? It is minus v by u. Then what is the magnification for convex lens? It may be either positive or negative. So for concave, the magnification is, it is positive or negative. So with respect to concave mirror, magnification is positive if and only if when the object is placed between P and F. Under that condition only, when the object is placed between P and F in front of a concave mirror, image is formed inside the mirror. So height of the object is positive, height of the image will also be positive. So therefore, magnification is positive. Apart from this, in all other cases, you may place the object at F or between C and F or at C, beyond C, even at infinity. In all the cases, image is formed in front of the mirror only. So there, object distance is negative, image distance, object, there, height of the object is positive, height of the image will be negative, right? So hence, magnification will be negative. And from this, we can also understand that if magnification is positive, then what is the nature of the image? It is virtual and erect. If it is negative, magnification is negative, it is real and inverted. Similarly, magnification for convex lens, convex mirror, it is always positive. M is always.
Sir, unmute your audio. Sir, unmute your audio. Sir, unmute your audio.
In case of sir.
Crossed, sir. Crossed.
Is it okay now?
Little crossed, sir. Your left side. No. Okay.
Okay. Yes. With respect to convex mirror, magnification is always positive because when the object is placed in front of the reflecting surface of the convex mirror, image is formed inside the mirror only, right? There and image formed inside the mirror, it is always upright. Object is upright, image is also upright. Both are positive, hence magnification will be positive, right? Okay. And even we have solved the problems on all the three. That is using this mirror formula and also finding the magnification in terms of heights as well as object and image distances. And the last one was, it was with respect to convex mirror, right? Last statement. Only one statement was given. Just I'll go for two more. Afterwards, we'll move on to the next concept. Right. And this has been given in the examination. And I've been taking this from all-in-one. I think it is this one. Right? Right. It is. If an object is held at a distance of 60 centimeters from a convex mirror, if an object is held at a distance of 60 centimeters from a convex mirror, a focal length 20 centimeter, full stop. At what distance? From the convex mirror? Should a plane mirror be held, so that images in two mirrors, images in two mirrors coincide. Full stop. So question mark. Next. If the height of the object is 10 centimeter, then find the height of the image form. Image form. Next. And sub question. Sub question is draw the ray diagram to represent the situation. Draw the ray diagram. Yes. Please go through the given state. It is, if an object is held at a distance of 60 centimeter from a convex mirror of focal length 20 centimeter. These are the two terms they are given. With this information, we have to find out at what distance from the convex mirror should a plane mirror be held so that image in two mirrors coincide. Now, no need to go through this statement. Let us focus this afterwards. Just go through only the first sentence. Here they are given at what distance the object should be placed. It is 60 centimeter from the convex mirror. Next, and the focal length is 20 centimeter. With this information, what we can find out? You can find out the image distance or position of the image. So first let us focus on that. Then we will move on to the sentence afterwards. Here still we have some more sub questions. We'll focus on that. Right. That. It is. Object is held at a distance of 60 centimeters from a convex mirror. What has been given?
Object distance.
Object distance is denoted by U. U equal to
Minus
positive
60.
minus 60.
Minus
negative 60 centimeter. Next, from a convex mirror of focal length 20 centimeter. Focal length has been given. F is equal to
positive, sir.
20 centimeter. Whether it is positive or negative?
Positive.
Positive, sir.
Positive. We know that focal length of convex mirror is always positive.
Positive.
Right. Positive. And then height of the object is given. How much? It is 10 centimeter. And right, H0 is equal to 10 centimeter. Positive or negative? This is also positive. First, let us focus on finding the at what distance image is formed. So obviously we have to use mirror formula, right? By mirror formula, then it is 1 by F is equal to 1 by U plus 1 by V. Substitute and cancel. 1 by where F is 20.
15, sir.
U is minus 60 plus 1 by V. It is 1 by 20. Transfer minus 1 by 60 to the left hand side. It becomes plus 1 by 60, then which is equal to 1 by V. Take LCM. LCM is 60, then it is 20. 3s are here 60, 1s are. It is 4 by 60. 4 by 60 is nothing but 1 by 50.
By 15.
It is 1 by 15 is equal to 1 by V. V is equal to positive 15, right?
Sir.
Now we have come to know that image is formed at a distance of 15 centimeter from the mirror, whether it is inside or in front of the mirror. It is
Inside the
formed.
front of the mirror.
That is one conclusion is over. Then, okay. And before going to this, again, let us focus on this. It is, if the height of the object is 10 centimeter, find the height of the image. But how do you go for finding?
By magnification.
Magnification formula. So we all know that magnification, it is equal to HI by S0, which is also equal to minus V by U. We want height of the image. So let me write this height of the image as it. Next, height of the object. It is unknown. Sorry, it is known. It is 10 centimeter. Then minus where V is 50 and U is minus 60. It is HI is equal to, here minus can cancel, 15 by 60.
1 by 4.
4, sir.
1 by 4. Cross multiply 10. It is 1 by 40. And this can also be written as, it is 0.0. It becomes 100. Then 2s up. 80, it becomes 20. Then if you take 0, it will be 200. It is 5. 0.025 centimeter. Obviously, we all know that image formed will always be diminished in case of convex. Yes.
Sir.
Yes. Huh?
Sir, multiply 10 to the numerators. Sir.
Sir, 15 by 60 is 4,
Yes,
sir.
sir.
2.5 will come, sir.
2.5.
It is equal to 1 by.
It's correct, sir.
Now, it is 1 of 4, huh? It will be 10 by 4.
2.5.
2.5. Sorry, it is correct. 2.5, yes. Okay. Now, let's go for drawing the ray diagram. Then we should focus on that. Let me draw the ray diagram here only. Take scale and pencil. Ray diagram. Draw a straight line. And go on marking for every unit distance. Let that unit distance be 2 centimeter. Here 2, 4, 6, and 8. I call this point as C, center of curvature of convex mirror, and this point as F, principal focus, and this point is P, pole of the mirror. Now, if you are using the compasses with the CS center CP as radius, draw an arc. As this is convex mirror, the reflecting surface should bulge outward to show the non-reflecting surface. They have given the focal length of the concave mirror, sorry, convex mirror, it is 20 centimeter. So let me mark that. It is 20 centimeter focal length. At what distance object is placed? 60 centimeter. It is placed at a distance of 60 centimeter from the mirror. Up to here 20, then this is 40, next it is 60.
At infinity, sir.
Here I'll go for extending this.
So it is behind C, sir.
This is 20, 40, and this is 60. Now, place the object at a distance of 60 centimeter from the mirror. Then you have to draw the first ray. First ray is a light ray coming from the object incident on the mirror parallel to the principal axis. And we all know that this ray gets reflected, and this ray, the reflected ray, appears as if it is emerging from the focus. Then what is the second ray? Second ray of light incident on the mirror in the direction of center of curvature. And we all know that this ray gets reflected, and the reflected ray moves along the path of incident. And identify the rays meeting point. Reflected rays will meet at a point inside the mirror. So from that intersecting point, draw a perpendicular. This is image. So now name the object as AB, image as A dash, B dash, and this convex mirror as N dash.
Vedant Varnekar. Vedant Varnekar. Mute your audio. Raju sir, he is a new student.
Vedant. No.
Vedant Varnekar, he is a new student.
No, sir.
Okay.
Ora?
Sir.
Yes. We have drawn the ray diagram. Have we shown the object distance?
60
Object
centimeters.
distance is 60 centimeter. 60 centimeter. Height of the object is 10 centimeter. Can you stop? Okay. Now, please go through this second sentence. At what distance from the convex mirror should a plane mirror be placed so that images in two mirrors coincide? Did you understand the statement? At what distance? Obviously, we have to place the plane mirror in between P and P only, right? At what distance from the convex mirror should a plane mirror be placed so that images in two mirrors, that is, image is formed inside this mirror, that is convex mirror. And if you go for placing the plane mirror here, obviously the image of this is formed, that is A dash B dash. Hence we can say that it is coincide with each other. Got it? No. But at what distance the mirror should be placed? That's the question. We do not know that. Hence, I go for choosing the point here. Let us call M is the M is the place at which plane mirror is placed. So, let me draw. If I want to get the image of this object, this should be non-reflecting surface, right? Any point. First, let us choose any point. With the calculation, let us go for satisfying the statement. At what distance from the convex mirror should a plane mirror be held so that images in two mirrors coincide?
Sir, in the plane mirror, the object distance and the image distance are equal. So we should place between the object and image equally, sir.
So I've taken BM and MB dash.
No, sir, we should add a 60 centimeter and 15 centimeter, sir, of image distance and object distance. Then we should divide by 2.
Should be 40. No. Wait. Let's do one thing. You just stop over there. Afterwards, I'll discuss. I'll go for discussion.
Sir,
Just to leave around 5 lines.
sir, we can do it as,
Diagram as it is.
sir,
Yes.
we can keep it in the midpoint of the, in between the object and the image font. Then the image will be coinciding. No, sir. If we place in between the object and the image formed by the convex mirror.
We have done the same only. Of course, yeah, as you are telling, what you are telling, it is right only. But with calculation, we have to show. Wait, let's not waste our time. Just leave around 5 lines. Afterwards, we'll go for discussing. Now we'll go for giving you another statement. This is right. Find the distance at which find the distance at which an object should be placed. An object should be placed in front of a convex lens. In front of a concave mirror. A focal length. A focal length 10 centimeter. 10 centimeter to obtain an image, first one of its same size, second one of double its size, Hope that you have understood the given statement. Have you understood?
Yes, sir.
Go through that. See, find the distance at which an object should be placed in front of a concave mirror of focal length 10 centimeter to obtain an image of its same size. You all know that under what condition the size of the image is equal to size of the object.
When the object is placed at C.
At C, center of curvature.
When the object is placed at C, then image height of the image is equal to height of the object. That's one thing. And even the distance of the image and distance of the object will also be same,
Equal.
right? But that should be shown with the calculation. Focal length to obtain an image of its same size. Then
20 centimeters.
What will be the distance?
20 centimeters.
20
It will
centimeters.
be placed at 20 centimeter. Clear? Next, and another one is of double its size.
40
We have to get the
centimeters.
image of the object whose size is whose size is 2 times that of the object. That should also be shown with the calculation. So let's go on. Right. Data. It is focal length is given, f is equal to 10 centimeter. Positive or negative?
Negative, sir.
Negative, sir.
Yes, sir.
Focal length of concave mirror is negative. Only this much has been given. Now let us go for taking one by one calculation. First one, look here, we have to find out the distance at which object should be placed to get an image whose size equal to size of the object. That means, what should I write here? Size is nothing but height of the object and height of the image. So
By
height of
magnification.
the image and height of the object both are equal, according to the first condition. Then how do you come to know the distance? Because distance it should be placed at 20 centimeter, right? R equal to 2f, of course it is. It is. But you, for this condition, how do you go for calculating?
Sir, calculating object distance and image distance.
We all know that hi by h naught is equal to minus v by u, right?
Yes, sir.
Yes, sir.
Then hi and h naught both are equal. If they are equal, then what it will be?
One, sir, one.
One,
Okay.
sir.
Then further,
Minus 1 by 1.
v by u. Then
Minus v is equal to u.
minus v is equal to u, right?
Sir.
Then please don't go for calculating, just observe. You want the distance. So 1 by f is equal to 1 by u plus 1 by v. Then 1 by where f is minus 10. U, we want that distance, that object distance, then plus it is 1 by v. V is what? It is minus u. Then both get cancelled now. Can you identify where we have done the mistake?
Distance is 10 centimeters, sir.
Not 10 centimeter. Focal length is 10 centimeter.
Sir, it is double, no, sir?
Only we are focusing on only first case. Here, hi by h naught will be minus 1. Alva? Then v is equal to u.
Sir, their minus get cancelled, no, sir.
Then this will be u. And this will be 2 by u. And this is minus 1 by 10. And it is minus
2 is equal to minus 20.
Is equal to 1 by u is equal to minus 20. Did you understand?
Yes, sir.
Did you understand?
Yes, sir.
No.
Sir.
Okay. Some of you are telling it is no. I'll tell you. The students, we know that in case of concave mirror, image is formed. Image is formed on the screen means whether it is upside down or upright.
Upside down, sir.
Upside
Inverted.
down, nothing but inverted. For inverted image, height will be negative. Got it? So, this is okay. Height of the image and height of the object. Of course, both are equal. Both are equal. Then, and magnification will be minus 1 for that. because height of the image is negative, height of the image is positive. Here I write m is equal to negative -1, and this is equal to minus v by u as it is. Here minus minus get cancelled. V is equal to u. Clear? Then mirror formula. 1 by f is equal to 1 by u plus 1 by v. Then 1 by, where f is -10, then 1 by u plus 1 by v, where v is nothing but u. As we need object distance, so I am taking substitution for v. V is nothing but u. 1 by u plus 1 by u, it is 2 by u. Then cross multiply, it will be -1 by 20. Then u is equal to -20. Object distance will always be negative. So object should be placed at a distance of 20 centimeter from the mirror. Is it clear? Any doubt?
No,
Here,
sir.
No,
do
sir.
you have any doubt?
No, sir.
Chandra, do you have doubt or not? No doubt. Samiksha, Saunav? No doubt. Hope that you have understood. Sahasra, Varnita, Nishka, did you understand? Yes. Okay. Aditya? Okay. Yeah. Now you may go for copying the same. We know that here by mirror form. If your writing is over, then write the conclusion for it. Therefore, the object should be placed at a distance of 20 centimeter from the mirror. Therefore, the object should be placed at a distance of 20 centimeter from the mirror. Over. Yes. Shall I repeat?
Yes, sir.
Now we are moving to second one. Calculation for second one. Observe it. Now this time we are going to find out at what distance the object should be placed to get the image which is double of the height of the object, which means height of the image is
20.
2 times the height of the object. H is equal to 2
40,
times
sir.
of HI is equal to 2 times of H naught. Got it? Please stop writing and observe. Same type calculation of the here. It is HI by H naught is equal to minus V by U, where HI is equal to 2 H naught by S naught. Should it be negative or positive?
Positive, sir.
Negative.
Negative.
Height of the object is positive. Image is formed, it is negative. So that it will be negative. Followed because magnification is negative. Magnification negative itre matra namage image it is formed on the screen. Got it? Now it is equal to minus V by U. Both get cancelled. It is -2 equal to minus V by U. Minus minus get cancelled. Then 2 is equal to V by U. Then V is equal to 2U. Did you understand?
Sir.
Next, mirror formula, same only. It is 1 by f is equal to 1 by u plus 1 by v, then 1 by, where f is minus 10, it's equal to 1 by u is unknown plus 1 by v is, it is 2u. Then 1 by or minus 1 by 10 is equal to, what is the LCM? 2u. Then 2 plus 1 minus 1 by 10 is equal to 3 by 2u. Then solve u, cross multiply. U is equal to, it is 30 by 2.
Sir, minus. Sir, we know you know, sir.
Minus 30 by 2. Then it's equal to minus
Minus
50. Got it? So object should be placed at 15 centimeter. Then only we will get the image which is, whose size is double of the object. Hope you have understood. Please just look at the board. 1 minute. Okay. This is concave mirror. This is 4 is principal focus. This is center of curvature. And they are given focal length is 10 centimeter. From here to here, 10 centimeter. Now we are placing the object at 15 centimeter means
In the focus and the center of
Between
curvature.
C and F.
between C and F. We will get the image beyond C, and the image formed is
Inverted.
bigger than the object. Alva?
Inward.
Followed or not?
Yes, sir.
That is, hence, what calculation we have done, it is correct. Copy it. Ora. Great conclusion. Shall I rub it? So now we are moving to uses of concave as well as convex mirrors. Right. Uses of concave mirror. Yes. Yes, students, we are very familiar with the concave mirror, where the light rays will converge at a point after the reflection, so that because of this property, we will go for using it for many purposes. Could you tell one by one? Yeah. We all know that doctors go for using a mirror to get the enlarged image of the teeth, right? And for that purpose, they go for using concave mirror only. So it is used by, right? It is used by dentists to get the enlarged image of teeth. Written up. Okay. Then any other? It is also used as a
Headlight.
dressing
Shaving.
mirror
Shaving mirror.
and is also
Vehicle
used
headlights,
as a
sir.
shaving
Vehicle
mirror.
headlights.
Because when we all know that when the object is placed between P and F, then we will get the image, upright image, and it is bigger than the magnified. We'll get the magnified image that is bigger than the object. So it is used as dressing mirror and shaving mirror. Ora, listen. In the vehicle's headlight, see that here is the bulb. We all know that here the light get spread out, right? Because back side of that light there will be a reflector. That reflector is nothing but concave. Got it? It is used as a
Sir, in torch, sir.
huh?
In torch.
Yes, in torch also. Hope that you are understanding. Okay. This is headlight. In that, this is the reflector. Here is the bulb. The light will spread like this. And these light rays get parallel to each other after the reflection. So therefore, it is used as a reflector. It is used as reflector in vehicles, headlights, torches, and torches. Next.
That is also used to concentrate sunlight, sir, to produce solar energy.
Yes, sir.
That is in solar furnaces.
furnace.
Solar furnaces. This has a reflector because it will focus the light on the it will focus the light incident on it, and so that all the light rays will fall on the furnace. So, right, it is used in solar furnace. These are the few uses. Written up.
TV antennas. Sir.
TV antenna, that will be in that shape only. TV antenna dish, it will be in the shape of concave. But here we are using the concave mirror. Okay, these four are enough. Next.
Light out.
Uses of convex mirror. Convex mirror.
Used as rear view mirrors, sir,
Yes,
in vehicles.
obviously. You all know that in the vehicles, as a side view mirror, we will go for using convex mirror. What is the reason? In case of
It
convex
gives
mirror,
a wider field of view.
It shows the image part of the vehicles.
we will always get erect image. One thing. Then as the object is brought closer to the convex, the size will go on. increasing. So that is why it is used as a side view mirror in vehicles. It is used as side view mirror in vehicles. And you also might have observed that in shopping malls there will be a big mirror and near the door only. Hope that you have observed that it is used as a security mirror in the shopping malls. Got it? Right. It is used as security mirror even you might have noticed that in the traffic signals, a big mirror is to be placed on one side.
Yes, sir.
Yes, sir.
So that is
Sir.
also
Convex
a
mirror.
convex mirror. Right. It is used in traffic signals.
Sir, why it will be placed, sir?
The reason is, see, as you are approaching that, you'll get the enlarged image of the other vehicles which are coming, so that accidents can be avoided. That's why it is to be placed. So these are the three important uses of convex mirror.
Sir, it is also used in street lights, no, sir?
Yes, yes.
Convex mirror. It's also used in street lights, convex mirror.
As a reflector. No. Convex mirror will not be used.
Sir, in lighthouse.
He is telling that in the street light. A street light and then just glass irutte, which is bulged outward.
Sir, what is the second point of convex mirror, sir?
It is used as a security mirror. Over. Now we are moving to the next concept of this chapter. Reflection concept has been completed, except this one. Let us discuss that later. Now we are moving to the next part of this chapter. Here, just I'm going to give you a situation where we will go for taking some amount of water in the beaker. Next, in this beaker, I'm going to place this marker. Observe this. You can notice that when it is inserted in the beaker containing water,
It is convex
some
mirror, sir.
part of the marker, it is above the surface of water, and some part is below the surface of water. Then how does the part of the marker which is inside the water appear?
Larger than the object.
It is
Larger
larger.
than the object.
It appears thicker than the object, actual size, right? Is it not?
Yes, sir.
Similar.
Sir.
I'm going to place it slant.
It is thicker than the original
It is
object.
thicker than the original and larger.
Okay, just
It appears like two.
how does it appear?
Bending, sir.
Again, the same thing. The part of the marker which is inside the water appears thicker than the
Thicker.
actual size.
Actually.
Look here. Next, and you can also observe the surface of the water. The surface of the water at which how this marker appears. Can you tell?
It's bent, sir.
Yes, to bend.
Thinner, sir.
Yeah, anybody can come and observe and tell. You just observe at the surface of the water from outside. Just observe and tell. You come and observe and tell.
So it looks like breaking.
Ah, wait.
Bedding, sir.
Wait.
It's
ಈಗ ಇಟ್ಕೊಂಡು ನೋಡು. How does it appear? ಇಲ್ಲಿ ನೋಡು.
the two objects are joined, sir.
Wait.
Sir, the color like it appears in the water is white color.
No. I am asking you, when you observe the marker at the surface of water from outside, ಇಲ್ಲಿಂದ ನೀನು ನೋಡಿದ್ರೆ ಹೆಂಗ್ ಕಾಣಿಸ್ತಾ ಇದೆ?
Sir, line, sir, scale line.
It looks like it's cut. It's cut.
Enlarged, sir.
No.
It's breaks.
It's break.
Sir, it bends
It appears
downward.
as if it is broken, ಕಟ್ ಆಗಿರೋ ರೀತಿ ನಮಗೆ ಕಾಣಿಸುತ್ತೆ. Yourself. Now we have to observe the part of the marker which is inside the water along the marker. ಇಲ್ಲಿಂದ ನೋಡ್ಬೇಕು. Observe from here. Not here, from here. Yes. See, when you observe the marker from this part, ಈ ರೀತಿ ನೋಡಿದ್ರೆ, from the top, when you observe that marker, the part of the marker which is inside it appears as if it is bend ಆಗಿರೋ ರೀತಿ ಕಾಣಿಸುತ್ತೆ. Now also it appears as if it is bent. Do you know what is the reason in all the three cases?
Reflection of
Reflection
Sir,
of
because
light.
of the light
Reflection
will
of
pass
light.
through water in
Deviation of light.
We tell you that. Look here. In the first case, we place the object perpendicular to the surface of water. We place the object inside the water perpendicular to the surface. But in this case, it appears the part of the marker which is inside the water appears thicker than the actual size. Next, in the second case, we placed the marker in slant position. When it is placed in slant position, and when you observe the marker at the level or at the surface of water from outside, ಇಲ್ಲಿಂದ ನೋಡಿದಾಗ, then it appears as if it is broken. And here also you notice that this part, the part of the marker which is inside the water, appears thicker than the actual size. And in the third case, we place the marker in slant position like this, and you observe from here, then you notice that the part of the marker which is inside the water, it is bent. Got it? So for all these cases, one phenomenon of light is responsible.
Refraction.
Refraction.
It is called refraction. And before going to give the definition, let me go for giving you two more situations. Example, assume that there is in a sweet stop, in a jar, some number of jamuns are there. They are placed in the sugar syrup. When you see them from outside, they appear bigger, but actually when they are taken out from their jar, you'll come to know that its actual size is smaller than the appeared size. It is due to this refraction of light only. Then let me give you one more situation. Assume that there is an aquarium. Inside this, many fishes are there. And you will go for trying to catch them. Is it possible to catch easily?
No, sir.
No, sir.
Actually, when you go for catching them, they will be moving still in the depth level only. But for you, it appears as if they are moving in the upper part. So that is why you find it difficult to catch them. It is also because of refraction. Then why it happens in all these cases like this? Here, when you are observing the object, the light will be traveling from one medium to another medium. Now, here I am observing the object inside the water, means the ray of light, it is in the air. Now it will enter into the glass. Then it enters into the water. Here, light is traveling from one medium to another medium. On traveling, it will go for changing its direction. Do you know the reason for changing its direction?
Change in speed.
Yes, it is. We all know that the velocity of light is different in different medium. As it travels from one medium to another medium, due to the change in the speed, it changes its direction of motion also. And we call this phenomenon as refraction of light. Now let me tell you the definition. When a ray of light traveling from one medium to another medium, it changes its direction of propagation. This is known as refraction of light. Followed. So when it is traveling from one medium to another medium, it may bend away or it may bend towards. There is a condition for that also. Now let me give you the condition under which the refraction of light takes place. What is the simple condition? What is the
Change
cause
in medium.
for refraction? Velocity of light is different in different medium. That's all. Here, I'll go for taking the three states of matter. One is air, second one is water, and third one is
Solid.
gas. So first one is gas, second one is liquid, third one is solid. Could you tell in which of these three light can travel faster?
In air, sir.
In air,
Yes,
sir.
sir.
Yes, sir.
What's the reason?
As particles are
Particles are
Loosely arranged.
Loosely arranged. They are randomly moving.
We all know
The
that
particles
in case
are
of
not
air,
in closely.
particles are arranged randomly. They can move freely. There is more distance between the particles. And the intermolecular space is more.
More.
Therefore, light can travel easily, which means it can travel faster. In water, the particles are arranged loosely.
Loosely
So,
packed.
observe the intermolecular space. In case of liquid, it is less than in case of gas. So that is why light travel with harder, light travel harder in case of liquid on comparing with gas. Hence, speed of or velocity of light is less in liquid than in air. Whereas in glass, that is in case
Closely
of
arranged.
Tightly packed.
particles are arranged tightly. So light will get less space for its movement. It will undergo the obstruction oftenly. Hence, the velocity of light is least in case of solid. Got it? The medium in which light can travel easily, and we call such medium as it is optically rarer medium. Optically rarer medium. Once I tell you, the medium in which light can travel easily or faster, it is called optically rarer medium. Then a medium in which light travels slower. It is called
Optically denser medium.
optically denser
Denser
medium.
medium.
Optically denser medium. See, when we are using these words, optically rarer medium and denser medium, we will go for considering only two mediums. If you take air and water, could you tell which is optically rarer medium?
Air.
Air.
Air, sir. Air.
Water.
When you take
Water.
when you take
Water
water
is
and
a
glass,
rare
which is
medium.
rarer
Water
medium?
is the last one.
Water is rarer.
Water.
Glass is
Water is
denser.
rare.
Glass. Got it? Right. The side any refraction of light.
Sir, is the phenomena of refraction of light is used in the formation of lens?
Certainly, definitely. We'll go for discussing about lenses under this concept only, that is refraction. Right. Refraction of light. Refraction of light. Right. It is when a ray of light, travels from one medium to another medium. When a ray of light travels from one medium to another medium, it changes direction of motion. It changes its direction. When a ray of light travels from one medium to another medium, it changes the direction of motion or its direction. So this phenomenon is known as refraction of light. Refraction of light.
Sir, can we define refraction as bending of light, sir?
Bending of light, of course, it comes in another phenomena called diffraction. Hence, we will go for writing like this. A ray of light travels from one medium to another medium. On traveling, it changes its direction. This is known as refraction. Right. Cause of refraction of light. Cause of refraction. What is the cause of refraction? The velocity of light is different from one medium to another medium. Refraction of light is caused due to change in the velocity of light from one medium to another medium. One medium to another medium. Next, These two terms are important. One is optically rarer media and second one is optically denser media. Right. Optically rarer media. Right. The medium in which the velocity of light is more. The medium in which the velocity of light is more. Medium in which the velocity of light is more is called optically rarer medium. So in general, we'll go for taking A is an example for optically rarer medium. Next, optically denser medium. Optically denser medium. The medium in which light can travel slower. The medium in which light can travel slow. It's called optically denser medium. Example. Okay. With respect to A, I can take water and glass as denser medium. With respect to A, if you consider air as rarer medium, then water will be denser, even glass will also be denser. Sure a bit? Listen. So we have an experiment to show the refraction of light. That is, when a ray of light is traveling from one medium to another medium, it changes its direction of propagation. Followed? So now let me go for explaining that activity. Even that activity will also be conducted. So first, I'll explain it. Right. Experiment. Experiment. Right? On refraction of light. Refraction of light. Here, the aim of the experiment is to show the refraction of light through a rectangular glass slab. Do you know about glass slab? Glass slab.
Yes, sir.
It is like this, the cuboidal shape. Here it is. This is rectangular glass slab. Right. To show the refraction of light through a rectangular glass slab. Listen to me. We need some of the materials to conduct this activity. The materials required are, one is rectangular glass slab, just which I show. Next one, we need
Pins.
a drawing sheet, then head pins are thumb pins. Thumb pins are required, then scale, pencil. So these are the materials required. So even drawing board also. Now let us come to know how these materials are to be arranged. Observe. Don't go for copying anything. Just you have to observe. Assume that we have taken a drawing board. Then we will take or we will spread the drawing sheet on the drawing board such that there are no wrinkles. So, or else you may go for fixing the drawing sheet to the drawing board using the clips. Such that there are no wrinkles. Next, you'll go for taking a rectangular glass slab and place it at the middle of the drawing sheet. Got it? Then take a pencil, mark along its boundary. Next, after that, you'll go for naming this as A, B, C, D. Next, take two pins, two head pins, and fix them against to the side, either CD or AB. I'm going to take two pins. This is first pin P1 and second pin P2. Followed, these are the two pins. You need to fix two pins against to the surface CD, and it should be, these pins should be perpendicular to the drawing sheet. Next, take two more pins and fix the third pin P3 against to the surface, against to the face AB by observing P2, P3 and P2, P1 and P3 through DC. Did you understand? Arthaita?
Sir, once again, tell sir.
This is a rectangular glass slab. Here, assume that this is the face CD. Here you have already fixed two pins. This is pin, this is P1 and this is P2. You are going to fix another pin against AB on this side by observing all the three pins through this face. Did you understand now? Such that they appear as if they are in a straight line. So we are fixing the third pin. Next, we will also fix the fourth pin. And when you observe P1, P2, P3, P4 through DC, from the P2, they appear as if they are in the same line. Andre, you glass ಒಳಗಡೆ ನೋಡಿದ್ರೆ ಎಲ್ಲಾ pins ಕೂಡ straight line ಅಲ್ಲಿ ಇರೋ ರೀತಿ ಕಾಣಿಸುತ್ತೆ. Not only that, even you can also observe all the pins from P4 through AB. Again, they appear as if they are in a straight line. Then after that, you'll go for removing the rectangular glass slab. Then take scale and pencil. Then remove P1, P2, P3 and P4. All the pins. Join P2, P1 and extend it to the face DC. Similarly, here, remove P3 and P4. Join with the scale and pencil. Next, look here. This line will intersect CD at a point. I call it as P. And these 2 points when they are extended, when the line is extended, they intersect AB at point Q. Let me join P. How does this PQ appear? Will it appear as it in a straight line or it's bent?
No, sir, it's bent.
Bent, sir.
It is bent. Alva, then the light ray is traveling from air medium to this glass medium. As it has changed its speed, so it changes its direction of propagation. And this is the activity related to refraction of light. Got it? Very simple activity, and explanation is also very simple. Now let me tell you the point wise. Listen carefully. First, take a drawing sheet and fix it to the drawing board using brass clips or using just clips. First point is over. Second point, take a rectangular glass slab and place it at the middle of the drawing sheet. Use scale and pencil. Draw the lines along the boundary of the glass slab. Second point is over. Third point, name the rectangle as ABCD. Fourth point, take two head pins P1 and P2. Fix them on the drawing sheet perpendicular to its surface against the face CD. Got it? Next, take third pin, fix it on the drawing sheet against the surface AB by observing from P2 through DC. Clear? Such that they appear as if they are in a straight line. Similarly, fix fourth pin also against the face AB. Then after that, next point, remove the rectangular glass slab. Also, pins P1, P2, P3 and P4. Next point, join P2 and P1, extend it to DC to intersect it at P. Next, join P4 and P3 and extend it which intersect AB at Q. Next, join PQ. Followed, and it is observed that the PQ, it is observed that when the ray of light traveling from air medium to glass medium or glass medium to air medium, it changes its direction of propagation. So this bending light indicates the refraction has taken place. Clear? This is the activity. Very simple activity. Look here. I'll go for it is PQRS. Here it is for the sake of explanation. Here this is PQ is the ray of light which is in the medium A, then it incident on the surface of the glass slab, and we call this ray as incident ray. PQ is incident ray. Then when it enters into the glass slab, it gets bent, and that bending ray is QR, and this QR is called
Refracted ray.
refracted ray. Refracted. Then and RS is the ray of light which is coming out from the slab, and we call this as emergent ray. Once I tell you, it is incident ray. This is a refracted ray, and this is
Emergent.
emergent ray. Followed. Incident ray, refracted ray, and emergent ray. And here, this is the point Q is called point of incidence. Point of incidence. And this is the point R from which the ray of light coming out from the slab is called point of emergence. Followed? Now let me go for drawing a normal and point of incidence as well as point of emergence. I name them as it is MN and this is XY. Followed? Now you can notice that by drawing the normal at the point of incidence, an angle is formed here. The angle is formed by incident ray and the normal at the point of incidence. What it is called?
Angle of incidence.
Angle of incidence. Then another angle is formed by the refracted ray and the normal drawn at the point of incidence. It is called
Angle of refraction.
Angle of refraction. Next, here, this point. Okay, this is the angle formed by the refracted ray and the normal drawn at the point of emergence. It's called angle of refraction and is denoted as small r. And one more angle is formed by the emergent ray.
Angle of emergence.
Angle of emergence.
Angle of emergence. These are the angles that are formed. One is incident angle of incidence, second one angle of refraction, third one is angle of refraction, fourth one is angle of emergence. And you can also notice that here the light ray has passed through the rectangular glass slab. Could you tell how many times refraction has taken place?
2 times.
Once or twice?
2 times.
2 times.
One is when it is traveling from rarer medium to denser, nothing but
Denser medium.
rare to glass. Second time, glass
Denser
to
medium to rare.
In general, we can say that when a ray of light passes through a medium, when it passes through that medium completely, it undergoes refraction twice. Got it? And you can also observe that here we all know that air is called a rarer medium and glass is called denser medium. Observe the bending of light when it is traveling from air medium to glass medium. And tell your observation with respect to normal.
It is
Tell your observation regarding the refraction of light with respect to normal. Whether it is bending towards the normal or moving away from the normal.
bending towards.
It is towards the normal.
Towards the
When a ray
normal.
of light traveling from air medium to glass medium, nothing but rarer medium to denser medium, it bends towards the normal. Similarly, observe when it is traveling from denser medium to rarer medium, how it is
Traveling
bending?
away from the normal.
Away.
It is
Traveling
bending away
Away
from the normal. Once I repeat, when a light ray traveling from rarer medium to denser medium, it bends towards the normal. When it is traveling from denser to rarer, it bends away from the normal. Still, we have some more conclusions with respect to this activity, this experiment. I'll explain those in tomorrow's class, including this problem. Okay. For today it is already time up. Now let me go for stopping the class. So tomorrow you will
Thank you,
have
sir.
the single form test, online performance test on this chapter only, refraction of light. Sorry,
Sir, key
reflection
answers
as well
of
as
weekly
refraction.
test.
Yes, with this, let's stop the class. Thank you very much.
Thank you, sir.